Welcome back to the deep dive. Today we are looking at a specific piece of code that I guarantee has tripped up almost everyone listening.
Oh yeah, it is an absolute rite of passage.
Right. It's that moment when you write a function in Python and it looks perfectly logical. I mean, it reads like plain English.
And yet,
it starts acting like it's, well, haunted.
haunted is a surprisingly accurate technical description for what happens here.
Right.
We're talking about data that just refuses to die.
Exactly. So today we are diving into what's known as the default trap. We're basing our conversation on a really insightful article called The Secret Life of Python, the Default Trap.
Written by Aaron Rose, yeah.
Oh,
Over at the tech-reader blog.
right. And our mission today for this deep dive is to understand why empty lists in function arguments turn into what the author calls zombies. You know, retaining data when they absolutely shouldn't, and of course, how to fix it using the industry standard.
It's a classic problem. And really, it's about how Python handles memory in a way that is just fundamentally different from what your intuition tells you.
I want to start by saying, I love Python. It's my go-to language.
Oh, totally.
It's supposed to be the friendly language. It's clean. It's readable. But this specific trap, it feels like a betrayal. It's like finding out your nice neighbor is actually stealing your newspaper every morning.
It can definitely feel that way when you first hit it. But the fascinating thing we're going to uncover is that this isn't a bug.
It's not.
No, it's not Python being broken. It's actually a feature of how the language is architected. It's about efficiency. But if you don't understand that architecture, it absolutely bites you.
Okay, let's get into the crime scene then. The article introduces us to a developer named Timothy.
Right, Timothy is our protagonist. He's sitting at his communal table, headphones on, and he's working on a project for a local chess club.
A chess club roster.
Oh.
Simple enough, right? He just needs to track who is signing up for classes.
Exactly, so he needs a function. He calls it addStudent. And logically, this function needs two inputs, the name of the student and the list of students to add them to.
So far, so good. We have def addStudent, parentheses, name, comma, student list.
But here is where Timothy tries to be clever, or rather just convenient. He thinks, well, most of the time, I'm starting a new class. I don't want to have to create an empty list and pass it in every single time I call this function.
That makes total sense. I mean, I do this all the time. You want the argument to be optional. You think, if I don't give you a list, just assume I want a new one.
Exactly. So he uses a default argument. He writes student list equals, and then just an open and close square bracket. He sets the default to an empty list.
I see this code in tutorials all the time. It looks so innocent.
It really does. And for the first call, it works perfectly. Timothy calls addStudent, passes in the string Alex. He doesn't pass a list, so Python uses the default, and it returns a list containing just Alex.
Great. The system works. Timothy leans back, takes a sip of his coffee.
Then he goes to add the second student. He calls addStudent, passes in Alice. Again, he passes no list, because he wants a fresh class for Alice. He expects the function to return a list with just Alice.
Because it's a new function call. New call, new list.
That's the intuition. But that is not what happens. The function returns Alex and Alice.
Whoa, wait, Alex is still there.
Alex is still there.
But I didn't pass Alex in. I called the function fresh. Why is the ghost of the previous function call hanging around in my new list?
That is the million-dollar question. Timothy is staring at his screen, completely confused. It's like he invited Alice to a clean room, she walks in, and Alex is already sitting on the couch.
That is unsettling. So in the narrative of the article, this is where Margaret enters. She's the senior dev, the mentor figure.
Yeah, she sees Timothy struggling and rolls over a whiteboard. She identifies the problem immediately. She writes 3 words on the board: function definition time.
Definition time. Okay,
Yeah.
break that down for us. Because to me, code is just text until I run it.
And that right there is the core misunderstanding. In a lot of languages, a function definition is just a declaration. It's just a blueprint. But in Python, the def statement,
The line where you actually define the function.
right, that line is actually an executable line of code.
Hang on. So when Python is just reading my script file and it hits that def line, it's actually running something right then.
It is. When the Python interpreter hits that line, it executes it. It creates the function object. And this is the critical part. It evaluates the default arguments at that exact moment.
At the moment the function is defined, not when it's called.
Only when it is defined, just once.
Wow.
So think about what that means for our empty list. Python sees those brackets, creates a list object in memory, let's say it's in memory address 500, and it attaches that specific list to the function object itself.
So the list is created once when the program starts up.
Correct. It is created once.
Okay, I think I need an analogy here because my brain still really wants to believe that every time I run the function, I get a new list.
Okay, imagine a gym with lockers. You're the manager representing the function. You tell your members, hey, if you bring your own bag, great. If you don't bring a bag, you can just use the default blue locker.
Okay, I'm following. So the default blue locker is the empty brackets I wrote in the code.
Yes. Now, member A, let's call him Alex, comes in. He didn't bring a bag. You point him to the default blue locker. He puts his gym socks in there.
Gross, but okay. Alex leaves.
Alex leaves. But,
Yeah.
and here's the kicker, you, the manager, you never cleaned out the locker. You never replaced it. It's the exact same physical locker.
So when Alice shows up,
Alice shows up without a bag. You say, use the default blue locker. She opens it, and boom, Alex's gym socks are still inside.
okay, that is gross, but it makes perfect sense. The locker wasn't created for Alice. The locker was installed when the gym was built.
Precisely. That installation is definition time. When you wrote student list equals empty list, you installed that locker. And because lists in Python are mutable, meaning you can put things inside them and change them without destroying the container, anything anyone leaves in that locker just stays there.
That completely flips my mental model. I always thought of a function as, I don't know, a factory that spins up, does its job, and then just vanishes. But you're saying the function object actually persists. It sticks around.
The function object persists, and its default values are stored right inside it. They're part of the function's luggage.
And Margaret actually proves this in the article, right? She doesn't just draw on the whiteboard. She shows Timothy the actual ghost.
She does. She introduces him to the defaults attribute.
Okay, defaults. It sounds like a debugging cheat code.
It's valid Python. Every function you write has a hidden property called underscore defaults underscore. It's a tuple that stores all the default values you set. Margaret has Timothy print this out.
So before he calls the function at all, just right after the program loads, what's inside it?
He prints the defaults for add student, and it shows a tuple with one empty list inside.
Okay, that's our clean, empty locker. Then he runs the function with Alex.
Right, and then he prints defaults again. And this is the smoking gun. The output has changed. It now shows a tuple containing a list, and inside that list is the string Alex.
The code of the function itself has changed.
The object representing the function has changed. The list inside that attribute has been modified. It's not just that the function returned a list with Alex, the function actually kept the list with Alex.
That is wild. It's like the function has a memory.
It does have a memory, and usually we do not want functions to have memory unless we explicitly ask for it. We want them to be stateless, input goes in, output comes out. This default trap breaks that rule completely by accident.
But wait, why doesn't this happen with everything? If I set a default, like say retries equals 0, and then inside the function I say retries plus equals 1, the next time I call it, it doesn't start at 1, it starts at 0 again. Why is the list special?
That is a crucial distinction. That is the difference between mutable and immutable objects.
Okay, break that down.
Integers, strings, booleans, and importantly, none. These are immutable. You cannot change the actual number 0. The number 0 is always 0. When you say retries plus equals 1, you aren't changing the object 0. You are throwing it away and pointing the variable at a brand new object, 1.
Gotcha. So I'm getting a new locker every time.
In a way, yes. You're getting a fresh value, but a list. A list is a container. You can add items to it, remove items, sort it, and it remains the exact same object in memory. It's the same locker. You're just changing the contents.
So the trap only snaps shut when you combine two things: definition time execution and a mutable object like a list or a dictionary.
Exactly. If you see def something and then a parameter equals curly braces, that's a dictionary. Run away. That is a trap waiting to happen.
So how do we fix it? Because I still want the convenience. I don't want to force the user to pass a list every single time. Timothy still wants to just say add student Alice.
This brings us to the professional standard. This is the pattern you will see in every high-quality Python library. You use a sentinel.
A sentinel, like a guard.
It's like a signal, a flag. Instead of using a mutable object as the default, you use none.
So the code becomes def add student name comma student list equals none.
Correct. None is immutable. It's safe. It doesn't matter that it gets evaluated at definition time because none is always just none.
But I can't append a student to none. If I try none.append Alice, the program is going to crash.
Right. So you have to add a check inside the function. This is the boilerplate you'll want to memorize. Inside the function, the very first thing you write is if student list is none, colon, student list equals empty brackets.
Let's trace the logic there. I call the function without a list. The default none is passed in.
The code checks, is this none? Yes. So then it executes student list equals empty list.
And that line, the one that makes the empty list, that is running at runtime.
Bingo. That line is inside the function body. It runs when the function is called. Every single time you call the function, that line runs fresh. It creates a brand new, shiny empty list right then and there.
So we've moved the creation of the list from definition time when the gym was built to runtime when the customer actually walks in the door.
Exactly. We are handing them a brand new bag at the door rather than pointing them to the old communal locker.
And because that new list is created inside the function call, what happens to it when the function finishes returning?
It gets garbage collected. It disappears. It doesn't stick to the function at all. The next time you call it, student list is none again, and you make a new list again.
It seems like a little extra work, though, writing that if statement every time.
It is 2 extra lines of code, but it buys you complete safety, and actually it gives you something else, control.
How so?
Well, none as a sentinel is very powerful. It explicitly tells you the caller did not provide anything. Sometimes passing an empty list and passing nothing might mean 2 entirely different things in your application. None lets you distinguish that.
That's a really good point. It's way more precise.
And Margaret points out to Timothy that there are tools to help you catch this early. If you use a linter like Pylint or Flake8 and you try to write list equals empty brackets in the arguments, the tool will actually yell at you.
It flags it as an error?
It flags it as a dangerous default value because the Python community has decided this is almost never what you actually want to do.
It is comforting to know the robots have our backs on this one. So we've solved Timothy's bug. He changes the default to none, adds the if check, and suddenly the chess club roster is accurate. No more ghost students showing up.
No more ghosts.
But I want to zoom out for a second. We've been talking a lot about lists, but you mentioned earlier that this applies to anything mutable. What else should I be watching out for?
Dictionaries are the other big one. If you write def function config equals empty dictionary, huge mistake. If you modify that config dictionary inside the function, that modification persists forever across calls.
Wow. And set.
Sets too. Even custom objects. If you have a class called car and you write def drive vehicle equals car with parentheses, you are creating that one specific car object at definition time. Everyone who calls the function without a vehicle is driving the exact same car.
That is a disaster waiting to happen.
It really is. It leads to incredibly subtle state bugs.
So let's recap Margaret's cheat sheet from the article. If you're listening and taking notes, when you're writing a function, what are the safe defaults?
Safe defaults are immutables. None. Integers like 0 or 1. Strings, tuples, and booleans like true or false. Those are all perfectly safe.
And the dangerous defaults.
Anything you can change after it's created. Lists, dictionaries, sets, and instances of your own classes.
And the fix is always the sentinel pattern.
Almost always. Default it to none in the arguments and handle the real default logic inside the function body.
You know, this conversation has actually changed how I view Python a bit. I used to think of it as this very high-level, abstract thing where I just didn't need to worry about memory management at all. But this proves that every abstraction has leaks.
All abstractions have leaks. And this specific leak, the default trap, is a great litmus test. It really separates someone who just knows the syntax from someone who actually understands the life cycle of the code.
The life cycle. That is the key word. Knowing when things are born and when they die.
Exactly. Timothy thought the list was born when he called the function, but it was actually born when the script loaded. That mismatch in mental models is exactly where these bugs live.
Before we wrap up today, I have a slightly darker thought. We talked about how the list persists in that hidden defaults attribute.
Yeah.
If I have a server running for months, and I have a function with this bug, and that list just keeps getting bigger.
I see exactly where you're going with this.
Should this actually crash my server?
Absolutely. This is a classic memory leak pattern. Imagine you're logging errors to a default list. Say def logger error, comma, log equals empty list. Every single error that occurs gets appended to that list.
And that list is attached to the function object.
Which is always in memory as long as the program is running. So that list grows, and grows, and grows. The garbage collector, the part of Python that cleans up unused memory, it never touches it because the function is technically still using it.
It's hoarding it.
It's totally hoarding it. You could wake up one day with gigabytes of RAM consumed by a single list in a function you thought was completely harmless, all because you didn't use none.
That is the stuff of nightmares right there. Zombie data just eating your RAM from the inside out.
It's a pretty compelling reason to stick to the none pattern, isn't it?
It certainly is. So the main takeaway for you listening today, don't trust the empty list in the argument. It's a trap. Use none. Be like Margaret.
And if you're ever unsure about what your function is holding on to, check the default attribute. The truth is always hiding in there.
Thanks for unpacking this with me. I'm going to go check some of my old code right now. I have a feeling I've left some lockers full of dirty laundry.
Happy debugging.
But I'll leave you, the listener, with a final thought to mull over. If functions can hold onto data in their defaults attribute without us realizing it, what other hidden memories might our code be storing that we just assume are being deleted? Something to think about next time you hit run. See you on the next deep dive.